Hi everyone and welcome to today's video. This is a B1 level science lesson, and today we're going to be talking about work and energy. So what is work? Look at the image below, and who is doing work? Have you ever pushed a shopping cart? When you push the cart and it moves, you are doing work, and this is because you use a force to make the cart move. So work happens when you use a force to move something. Force is a push or pull, and movement is when something goes from one place to another. So what work can you see in the picture? We see he's vacuuming the floor, sweeping with a broom, she's cleaning the mirror, and watering the plants. Those are all examples of work. All right, so now match each verb with the motion, verb of motion with the correct picture. So go ahead and try that on your own and then restart when you're ready to check your answers. So pull is number 2. Push is number 1. Carry is number 3. Roll is number 4. Drop is number 6. And lift is number 5. So when you do work, you use energy. So energy is the power to do things. You use your energy to ride a bike up a hill and push the pedals. We measure work in something called joules. If you lift a small apple, you use about 1 joule of work. To find out how much work we do, we can use a simple formula. Work equals force times distance. So if I push a box with a force of 5 newtons for 2 meters, I do 10 joules of work. Okay, so what can you remember? Go ahead and complete the sentences with the words in the boxes, and then restart when you're ready to check your answers. So when you lift a box, you do work. Work is done when a force is applied to an object and it moves. We measure work in units called joules. Force is a push or a pull. And energy is the ability to do work or cause change. So we have potential and kinetic energy. So they want you to put the sentences in the correct order. And in each one you can start with A, that's number 1. So go ahead and pause the video, try this on your own, and then restart when you're ready to check your answers. All right, so the correct order is potential energy is stored energy. And then number 2, it is energy that is ready to be used. For example, when you hold the ball high in the air, the ball has potential energy. The energy is stored because the ball can fall. And a stretched rubber band also has potential energy because it can snap back to its original shape. Kinetic energy is the energy of motion. It is energy that is being used. For example, when you drop a ball, it starts to fall. As it falls, the ball is moving. This moving energy is called kinetic energy. And another example is a car driving down the road. The car uses kinetic energy to move. Okay, so now answer the questions based on the text. Again, you can pause the video, try these on your own, and then restart when you're ready to check your answers. So what is potential energy? Oops, do that. Potential energy is stored energy. Which of the following are examples of potential energy? That would be a ball held high in the air and a stretched rubber band. What is kinetic energy? That's the energy of motion. Which of the following are examples of kinetic energy? A ball falling and a car moving. And what happens to the ball's energy when you drop it? Well, its potential energy changes to kinetic energy. All right, now we're going to talk about connectors. Connectors show relationships between ideas, so match the connector with the reason why we use it. If shows a connection. If you push a box, it will move. I'm sorry, if shows a condition. If you push the box, it will move. Because gives a reason why something happened. The ball rolls because it is pushed. When specifies a specific time or condition. When you lift the weight, you use energy. And so shows a result or consequence. She pulled the rope, so the bucket moved up. And then we use the zero conditional to talk about facts, laws, and things that always happen. So the sentence structure is if or when plus the present tense, the comma, subject, and the present tense again. So if or when you drop an object, it falls to the ground. So now complete each sentence following the structure of the zero conditional. According to Charles's law, if the temperature of a gas increases, its volume will expand, assuming the pressure stays the same. According to Coulomb's law, when the distance between two charged particles decreases, the force of attraction or repulsion between them increases. And actually this one doesn't seem like it's correct. Instead of will expand, it should be expands because they said that we use present tense, so I'm not sure why they have will expand. All right, we use the first conditional to talk about things that are likely to happen in the future. So here we use if plus the present tense plus the subject plus the future tense, separated by a comma when the if clause comes first. If an object is at rest, it will remain at rest unless a force acts on it. So complete each sentence following the structure of the first conditional. So if you drop an object from a height, it will fall towards the ground due to the force of gravity. If you increase the temperature of a gas, it will expand. If you apply more force to an object, it will accelerate faster. And if you reduce the friction between two surfaces, they will move more easily. All right, so now complete some sentences with the first conditional using if plus the present tense plus the subject and future tense. So if you push a ball, it will roll forward. And then go ahead and try making some of your own sentences using these if clauses. All right, now we're going to complete each sentence with when or because. And here are some examples. When gravity causes a book to push down on a table, the table pushes back up on the book. Neither the table nor the book moves up or down because the two forces are equal or balanced. So when a baseball bat strikes a baseball, the baseball hits back. The batter may feel some force running through his or her hands. When you push a ball, it doesn't move because the wall pushes back with an equal force. When you row a boat by pushing water backward, the boat moves forward. Now you're going to complete the sentences with one of the connectors. When you lift a book, you use energy. The machine needed power, so I plugged it in. If you push a box and it moves, you are doing work. However, if the box does not move, you are not doing work in physics. We do work when we lift a heavy backpack because we use energy to move it upward. All right, so now you're going to use these words to make some sentences with the connectors that are provided, and you might have to add some additional words. So you can go ahead and try these on your own, and then restart when you're ready to continue. All right, now we're going to read about friction, and then you'll be looking for any connectors. And before we read, here are some vocabulary words. Slip is a verb meaning to slide by accident and lose balance. Grip is a verb which means to hold something tightly. And reduce is a verb that means to make smaller or less. Now you can pause the video and read on your own, or you can follow along as I read. Friction is a force that happens when two surfaces rub against each other. When you slide a book across a table, friction slows it down. If you try to push a heavy box on the ground, friction makes it harder to move. Friction can be helpful. For example, it helps your shoes grip the floor so you do not fall. However, too much friction can cause damage, like when car tires are used too much and need to be replaced. We can reduce friction with oil to make machines work smoothly. So what is friction? So it's a force that happens when two surfaces rub against each other. What does friction do when you slide a book across the table? It slows it down. How does friction affect pushing a heavy box on the ground? Friction makes it harder to move. And why is friction helpful for your shoes? It helps your shoes grip the floor so you don't fall. And how can we reduce friction? Using oil to make machines work smoothly. All right, simple machines. A simple machine is a device that changes the motion or amount of force applied to an object. So match each machine with its name. All right, so number one is a pulley. Number two is an inclined plane. Number three is a wheel and axle. Number four is a lever. Number five is a screw. Number six is another lever. And number seven is a wedge. All right, so now look at the simple machines in real life and match the machine with its description. Pulley, a wheel with a rope or chain around it. It helps to lift or move heavy objects more easily. When you pull on one end of the rope, the other end lifts the object. So that would be number two. A lever is a long bar with a point called a fulcrum where it balances. It helps to lift or move something heavy. When you push down on one end, the other end lifts up. So that would be number one. An inclined plane is a flat surface that is tilted like a ramp. It helps you move things up or down more easily. Instead of lifting something up, you can push or roll it along the inclined plane. That's number three. All right, now match the measurement with the thing that it measures. So work is measured in joules. Distance can be measured in meters or feet. Mass is measured in pounds or grams. Acceleration is meters per second squared, and force is newtons. All right, so you're going to read the word problem and answer the questions. So Tom pushes a 20 kilogram box across the floor with a force of 50 newtons. The coefficient of kinetic friction between the box and the floor is 0.2. Calculate the work done by Tom to move the box 5 meters across the floor. So how much does the box weigh? Well, it weighs 20 kilograms. Is there friction? So yes, because he's pushing it across the floor. The coefficient of kinetic friction is 0.2. What is the measurement or force? That would be the 50 newtons. And what does the problem want the student to find? So it would be the work done, which would be measured in joules. All right, so here's the solution to the problem. Here are the guides for what each of these things mean. So if you want to calculate the frictional force, so frictional force equals the coefficient of friction, and Fn is the normal force. Fn equals m times g, where m is mass of the box and g is the acceleration due to gravity. So you get 9.8 ms squared. So Fn equals 20 kilograms times 9.8, 196.2. 196N equals 39.2. Here you calculate the force and the work done. So Tom does 54 joules of work to move the box 5 meters across the floor. All right, so now complete the word problem and solution with the correct words. Okay, so the problem, Samantha pushes a heavy box across the floor. She applies a force of 20 newtons. If she moves the box a distance of 5 meters, how much work does she do? So the solution is the force, 20 newtons, the distance, 5 meters. To find the work done, we use the formula. Work equals force times distance. So plugging in the values, we get 20 times 5 equals 100. So Samantha does 100 joules of work by pushing the box. Emma uses a pulley system to lift a 10 kilogram box to a height of 3 meters. The pulley system is 80%, I would say, efficient, meaning only 80% of Emma's input work goes into lifting the box. Calculate the total work done by Emma and the useful work in lifting the box. Liam is riding his bicycle up a hill. The hill has a height of 20 meters, and Liam and his bicycle together have a mass of 75 kilograms. If Liam applies a force of 300 newtons to pedal up the hill and reaches the top, calculate the work done by Liam against gravity to reach the top of the hill. And that brings us to the end of today's video. Please like, subscribe, share, leave a comment, and I hope to see you soon. Thanks for watching. Bye.